Hello, I'm Neil Kraft, President of Kraft Technologies. We're an analytical laboratory in North Carolina. My poster this year is about the development of a method to do the extraction of human brain and analysis of tocopherols, tocotrienols, and carotenes in the brain. We previously did this work. We were the first laboratory to actually measure individual carotenoids in the brain, and there were some things that might not have been the best way to deal with it at that time. The group that was interested in having the tocopherols measured had greater interest in those than they did in the carotenoids. So we wanted to be sure that we didn't create any artifacts, and so we felt it was best to try to avoid saponification, which is a method of hydrolyzing triglycerides and extracting the tocopherols away. The problem is that some of the tocopherols don't extract efficiently whenever the extract is alkaline, and that happens during saponification. So we developed an extraction method that does not involve saponification so that we can get good assessment of endogenous levels of tocopherols in the brain. We also tested a number of solvents. We looked at methyl T-butyl ether, hexane, SDS, and tetrahydrofuran as solvent combinations to make sure we efficiently extracted the nutrients. So what we found was that we were able to separate 8 isomers of the tocopherols and tocotrienols by using a normal phase separation. Because we used normal phase, it would actually tolerate the high lipid content that was in the extract. We also used fluorescence detection for the tocopherols because it's actually 4 to 10 times more sensitive than a UV detection is. So we also monitored the sample with visible and UV. The reason that we use the UV is because the alpha tocopherol is relatively high and actually could exceed the linearity of the fluorescence detection. So we have, at the very beginning, the carotenes come out, we change the wavelength to monitor alpha tocopherol, and then we pick up the xanthophylls, alpha and beta cryptozanthin, and lutein and zeaxanthin that are present in the brain. So in this case, we were able to measure, if present, all 8 isomers of the tocopherols, tocotrienols, and be able to measure the xanthophylls that were present. What we observed was that the difference in the extraction approaches was, I guess from the results, we found that methyl T-butyl ether and tetrahydrofuran provided best extractions of xanthophylls. Methyl T-butyl ether and hexane provided the best extractions of the carotenes, and then THF followed by hexane was the best for the tocopherols. Our approach for the Rush Memory and Aging project was to use an initial MTBE extraction followed by a mixture of hexane and THF to be sure that we were efficiently extracting all the carotenoids and all the tocopherol isomers that were present. It was important to look at this without saponification because there was some uncertainty as to what form the xanthophylls might be present in the brain. They may be present as lutein and zeaxanthin esters. We did not see any evidence of that in our analysis, and we did compare saponification to unsaponified fractions to determine if there was any loss of the tocotrienol or tocopherol isomers. At this point, we haven't found that there's a problem in doing the extractions using saponification, but the levels were so low for the minor isomers that we couldn't discriminate that. We plan to follow this up with spike samples of brain tissue in order to determine whether the alkaline conditions influence the extraction efficiency of these tocopherol tocotrienol isomers. I do have one other comment I'd like to follow up with. We also isolated the zeaxanthin component. Right here, the zeaxanthin component of the brain extracts, and then we did a chiral separation to determine whether zeaxanthin was present in which optical isomer form. So zeaxanthin has 3 optical isomers, the SS, the RS, and then the RR. In nature, the foods tend to have all RR zeaxanthin. So in this chromatogram, there's a standard of a racemic mixture of zeaxanthin. We have a standard of lutein. What we found in the brain extract is that only the RR isomer of zeaxanthin was present. We did have some lutein that carried over in our fraction that we collected. And I believe that confirms the work that was done by the Tufts group and Liz Johnson.